Hi everyone, welcome back to my channel. So I'm starting a series where I'm just going through one of the technical books. I will just go through few of the technical books in this series. So and then I will go chapter by chapter. Then I will try to record a video for each chapter or a section or a concept, and then try to upload it in this channel. So today we are just going through Designing Data Intensive Applications book by Martin Kleppmann. So if you can see, there are three parts in this book, that is foundations of data systems, distributed data, and part 3 is derived data. So if you are a software developer or a data engineer, or if you wanted to understand about distributed systems in general, then this book will be will give you a basic knowledge, or I can say foundational knowledge on these concepts. So it's really worth your time to go in depth by going through this book end to end. So I'm just trying to capture my understanding by creating these videos. So please ignore if my explanation doesn't make sense in some other scenarios. So I'm just trying to create a video for each chapter and try to upload them so that I can able to learn by myself and also understand it better. So I will just go through each of the chapter names. So first one I think is reliable, scalable, maintainable applications. Then the second one is related to data models and query languages. Third is storage and retrieval. Fourth is encoding and evolution. Then fifth is replication, partitioning, transactions, the trouble with distributed systems. Then consistency and consensus, which are there under distributed data section. Then under derived data part 3, we do have batch processing, stream processing, and the future of data systems. So I will try to go through each of these 12 chapters, chapter by chapter. So today I'm focusing on chapter 1, that is reliable, scalable, and maintainable applications. So basically previously I have recorded a video, but somehow the screen recording stopped. So I'm just recreating this entire thing. So previously I was making notes and creating a video, but now I will just go through what I have wrote down. So in this chapter, TLDR is that you have to understand what are these terms, like what is reliable, what is scalable, and maintainable applications. So here, when you are focusing on applications, it might be software application, any software system or software service, or a data systems. So generally, for building a software application, we might require functional requirements. So functional requirements are nothing but the features of the system. Suppose if you are concentrating on, suppose let's take an example of Netflix. So the features would be like selecting a specific, by in a search bar, selecting for a specific movie by entering its name. Then the user can able to see relevant results. That is one of the feature. Then ability to switch to different quality. So that is one of the feature. Then ability to select or store or create a new user. Those are some of the features. And for non-functional requirements, it can be, when you are watching Netflix, you should, it has to be a low latency, and it has to be it has to perform well, and it has to get the good quality and everything. So those comes under non-functional requirements. And these reliable, scalable, and maintainable, these qualities as well comes under non-functional requirements of this any application. So just think, in today's world, I think because of lots of data, these applications are becoming heavy data intensive rather than compute intensive, because there might be heavy data which is coming. We might have all the resources to compute them, but in general it is becoming a data intensive. And whenever you are referring for a data, you might come across database or cache, stream processing, batch processing, search indexes, and queues. So all these are related to data systems, but these works under, these are the concepts which are working for different purposes. All will store some kind of a data only, but the functionality and the timing of these specific concepts or tools might differ. And coming to, basically these are several tools which can be used for different scenarios. So like for searching, we can use Elasticsearch and everything. For recent data, we can able to fetch it from cache, and if cache misses, then we can able to get the data from databases. And for sending some asynchronous messages, we can use messaging queues. So all these functionality, it can be abstracted under API. So a specific client or a user, if he requests something, it has to go through some API call. Then and then internally, this API call, which might contain several internal API calls as well. So it might get the data. It might get the data either data from the database or from search indexes or from other API call. So this is just this API is just abstracting all these things. Like these are just the tools which I've described above. And you have to remember that in this chapter 1, the author just explained about what is reliability, what is scalability, and maintainability. That's it. So I'm just going through whatever was discussed. Now coming to reliability. So whenever you think about a word reliable, so let's take an example of application called Netflix. So Netflix or Google. So these applications might contain some fault. So let's say it might contain some software bugs or hardware faults or human errors. So all these three belongs to all kinds of faults. So these faults leads to failures. So that might result in the failure of the entire system. So in order to make these faults in order to make this application tolerant to this fault, so we have to think about it and make this entire application as a fault tolerant, so that it can avoid some software bugs, it can avoid, and we can able to minimize the hardware faults and also minimize the human errors. So let's take an example. In Netflix, there is a concept called chaos monkey, where they deliberately switch off few of the services. Let's say if the Netflix is running on 100 plus services, then they deliberately switch off 50 plus services, and they would just check if the entire Netflix is down or not, so that we can able to have an understanding of how reliable the entire Netflix application or service is. So that's the entire gist of this reliability. Now coming to scalability, as the name suggests, right? So let's just take an example of a Netflix application only. So during the initial years, it might acquire like 1 million plus customers, but during the course of a decade or 5 to 10 years, there is an increased number of traffic. Like there might be around 50 plus million users, or there might be increased load of consumption or increased data incoming, or and also increased complexity of the entire system. So all these factors which will affect the performance. So all these factors or parameters, also known as load parameters, so these will affect the performance of the entire system. So in order to make this system functioning, even if there is a lot of traffic, even if there is a lot of load, even if there is a lot of data incoming, then in that scenario we can just say that this application is highly scalable, because it can able to scale well along with the traffic load and data by having a vertical or horizontal scaling. Also, these there might be other factors like increased number of queries per second, increased number of requests per second, and increased storage. So these will also affect the scalability of the application, and we might need to do some horizontal or vertical scaling, or it has to be that application has to be scalable enough in order to accommodate all these things. And the performance of the application all depends on the latency and response times and throughput. So all these concepts are described in this chapter 1, and if you are reading along, and please go through this again. And coming to the maintainability, so as the name indicates, the application has to be, it has to be easily maintainable. So so in order to make it more maintainability, or make it more maintained, it has to be good operable. It has to have a good operability, which means anybody can easily, let's take an example of a Netflix application. The operations team has to operate this application easily without any complexity. And coming to simplicity, yes. So whenever a new person is dealing with this application, he has to feel simple. He has to feel. This application has to be very simple in order to understand, hiding all the complexities, and so we might need to have some abstractions so that a new user, or new person, can able to understand and add new features. Then availability. So as the name indicates, so we if the business needs to add more features, then this application has to be an extensible. It has to be modifiable, and it should allow for extending this application. So on a whole, we might need to make this application more maintainable. So this is just the summary of the chapter 1, that is reliable, scalable, and maintainable applications. The quick summary is that whatever the system which you are developing, the software system or data intensive system, it has to be reliable. So for reliability, it has to tolerant to all these faults like software bugs, hardware, and human errors. And it has to be scalable with increased traffic, increased load, increased complexity, and increased data, and also queries, request, and storage. And this the software system needs to be more maintainable. So we might need to make it more operable. It has to be very simple, and it has to be evolve. It has to have this quality like extensibility, modifiability, which makes it more evolvability. So that's it, guys. So this is just the chapter 1 of this book, Designing Data Intensive Applications by Martin Kleppmann. And I will try to add few more. All the videos. I think there are 12 chapters. So chapter 1 is done, and I will try to post all the rest of the chapters in the upcoming videos. Thanks for watching, guys.